Welcome to the fourth part of Sign In with Apple series. In this part, we will learn about creating a client secret, verifying the identity token, validating auth code, and fetching the access and refresh tokens. We will do all in detail. Let us understand how to create a client secret. We have to create a JWT token like this, and it has the following parts. First is the algorithm, which is the ES256. So we have to make use of this algorithm to sign the token with. This is the key ID generated from the developer portal. So when we make the key on the developer portal, sign in with the Apple key, this is the ID of that particular key. This is the team ID which is associated with your developer account. This is the token initiated time or the creation time, the expiration time of the token. This is the audience, which is always this https://appleid.apple.com, and this is the bundle ID of your application. These are the error sets you may encounter when you are calling this service to fetch the access and the refresh tokens. Mostly we get the invalid client, so it is fired when your client secret is not valid or it's an invalid identifier, and the invalid grant. So this is something like your token is expired, or maybe your authorization grant is, or the refresh token is invalid. And there are other types as well. We'll create a client secret using one of the libraries in Swift JWT, and for that I will be creating a new project. I'll just name it JWT testing, because ultimately all this code should be written in the backend, but just to show you like how the things are done, I am creating this project and I'll use the JWT kit here to create and validate the JWT. So I'll use this Qtura Swift JWT. I'll add as a dependency here. Add package, and that's it. Now I'm going to import Swift JWT and just give a run to check everything is okay. Everything is fine. Now jumping on the next step, I need to add keys. So this is where we use our keys. I'll click on plus. I'll give the name Apple sign in key. Sign in with Apple. Configure. I'll choose my bundle ID and click on save. Continue. And this will just register my key, which I'll use in creating client secret and doing other stuff as well. I'll click on register. So once it is downloaded, you cannot re-download it. So when you are really prepared to download this key, you can download it and keep it in a secure place. And yes, I have downloaded it, and this is the key ID. So once you download your key, now you have to add it in a project. So drag and drop in a project, click on copy items if needed, and click on finish. So now your key is added in your project to help in creating the tokens. Now I'll write a function, create client secret, and I'll call it in view did load, and we'll now create a client secret here. Okay, so first step, I need to have the path of my private key, and if you open this, you can see this is your private key. Okay, now this is the path. Now next step is to create the data from this private key. I can say private key data, or try data contents of, and URL will be private key path options dot all is mapped. So I'll write everything in guard let. So guard let private key path. So this is the URL. Then let us check this, that it is able to make the data or not. else return. Okay, now as we know that our private key has a key ID, so this is our key ID from starting from D till H. So this is our key identifier and we'll use it in our header. So first step is to create header. Let my header, or let header, and this is coming from the Swift JWT library. The header is in that. So if you go there and see, so this is the header in the Swift JWT header, and in this I'll pass KID. I'll only need KID for the time being, and this will be DGH and this will be this one. Okay, so this is my key ID, and now I have to add the payload. So I need to define my claims. So for that I need to create a structure, my claims, and that will be, you know, conforming to this protocol claims. And if you go to this protocol, you can see a lot of things like expiry date, initial date, etc. So we will use this to create our own claims. Okay, so we'll have some things. So we'll have few things. ISS is your team ID, IAT, and this will be date. Sub is your bundle ID of your application. Expiry, again the date. So these two will have a value, and we can have a AUD, the audience, which will be again a static string of appleid.apple.com. So these are my claims, and now I can make the claims. Okay, so let my claims, and I'll add everything, right? So first ISS, like I told you, it's my team ID. So I'll go back to my portal, and this is my team ID here. I'll just copy it. Now the date of creation of the token. SUB is the bundle ID of the application. So if you remember our bundle ID, this is our bundle ID of the application. Expiry date. So expiry date, I'm going to set this token expiry date date since now 3600. So I'm making this token available for 1 hour. So this is in seconds. Okay, and the AOD will be AppleID.apple.com, and that is fixed. Okay, so my claims are ready, my header with the key ID is ready. Okay, now I'll create the JWT. So let my JWT and it has this initializer. I'll pass the header and my claims. Okay, now like I said that I need the ES256 algorithm in the header to sign it with. So I'll create a JWT signer, okay, dot ES256, and I have to pass the data of the private key. And what is that? This one, private key data. Okay, and finally I'll write signed JWT, which is my final JWT, and obviously this will be in the iflet, because, or I can write do try catch. So let me write do try catch, that will be good. Catch, and I have to make it this var because I'm mutating it, I'm adding the signature. So now my signed JWT is ready, and I'm just going to print that my client secret, which is nothing but a JWT token, signed JWT. Okay, let us try running and actually looking like what is the token I am getting. Let me run in the simulator to see how the things are going on. So my simulator is up and running here, and yes, I have the client secret with me. Let me copy this client secret in our text pad. Okay, let us decode it and see like how it looks like. So jwt.io, I'll use that and I'll decode the token. So if you look at this token, we have everything. We have the algorithm ES256, we have the key identifier, and we have the initial time, we have the expiry time with us. So see, the time is 10:35 and this is 11:35, so it's valid for 1 hour, and it has a signature as well. So let us see whether this is a valid client secret or not. Now let us run the code to do the sign with Apple. And I'm going to sign with Apple, and this will be the first time because I have revoked the token manually in the settings. I'll do a continue, and I got a lot of things here. So I got the identity token as well as the auth code. Let's see identity token. Like I said earlier, identity token is a JSON web token and it has three parts: header, payload, and signature. Header has two nodes, KID and ALG. KID represents the public identifier of Apple. We'll discuss this later. ALG is the algorithm which is used to digitally sign this JWT token. This is used to verify the authenticity and the integrity of JWT, and the signature, of course. In this identity token, we have E and N. E represents exponent and is modulus, and we'll discuss this in detail later on. Let's see the identity token payload. This is the complete user information which we require. ISS is the issuer and it's always appleid.apple.com. AUD is the audience, which is the client bundle ID, your application's bundle ID. The expiry time of the token, the time when the token was created. Sub is the user identifier, which is returned in the Apple ID credential. Nonce, we'll discuss this later on. This is used to secure the request. It is being sent from the device in the request and then it is validated at the server. C underscore hash, I'm not sure what that is. I haven't used that. Maybe some sort of hashing is being done. Email. So this is the email which the user has selected. In this case, the user has selected hide my email. That's why we are getting @privaterelay.appleid.com. Email is always verified. Generally, it's always true. So if it's a private email, like I said, it's @privaterelay.appleid.com, and if it's not the private email, we'll have the value as false in this node, and we will have a proper email in the email node. Auth time and IAT is same. It's the authentication token generated time. Nonce underscore supported is true. Real underscore user underscore status is 2. It has three values. 0 is, I think, unsupported, 1 is unknown, 2 is likely real. Let us see what we get in the payload whenever a user authenticates with sign in with Apple for the first time. This is the payload, and the existing login and user tries to sign in with Apple. So it has one node missing, real user status. So real underscore user underscore status is only done when you are doing the Apple login for the first time, and then in the application it is returned as unknown, but it is never returned in the payload while decoding the identity token. There is one more node, transfer underscore sub. So this node only comes in the payload whenever your application is transferred to another developer team, and it represents that we need to migrate the user to the other team. So obviously changing the user ID in that case. So this claim is present only during the 60-day transfer period after transfer an application. Now let us see what is nonce. Nonce is created whenever we are creating the Apple ID request, the authorization request, and we pass the nonce in the request. Nonce is nothing but a randomly generated string. So it is passed with the identity token. So whenever the identity token and the auth code is passed to our backend, we also have to pass the nonce. So this value can be verified with the identity token provided as a part of successful AS authorization response. So whenever we are sending the token, the auth code and the nonce, so from our service, the nonce will be picked, and from the identity token, once that is decoded, the nonce will be compared. If they are both same, then it means there is no man in the middle tag and the request is successfully verified. So you can send the request this way. You can make some service at your end like verify identity token, and then you can send all the three things in the body: the identity token, the authorization code and the nonce, all in string. Now let us decode our identity token as well. So let me go back to the project and copy this identity token. I'll go back to JWT, and this is the details I'm getting it, which is fine. And if you see the identity token expiration time, so this is a 1 day time, 24 hours time. So 30th August 10:44, 31 August 10:44. So basically the identity token is valid for 1 day, but the auth code is only valid for 5 minutes. Now let us try to verify this identity token as well. To verify the identity token, we need to convert the identity token and auth code in string format. Then we need to send both of them to our server. Before using the token, we have to ensure that it was signed by Apple's private key. To verify the signature, we have to obtain the Apple's public key. And with the help of this URL, we can get the Apple public keys. By clicking this URL, we get a set of public keys. So we get 4 public keys, and if you can see, this is exactly not a public key, but we have a lot of information which can help to create a complete public key. In short, this is a JWKS, JSON Web Key Set. And the N and E are the modulus and exponent, and they are in base 64 URL encode, and we need to convert them into a number. Then only we can generate a complete public key which will help in verifying our JWT identity token. So we need to decode the token and do the basic validation first. We need to check whether the ISS node is exactly equal to https://appleid.apple.com. Then the AUD should be our app bundle ID. The tokens creation time should be less than equals to current timestamp. The expiration time should be greater than the current timestamp. And the nonce, if we send the nonce along with the identity token and auth code to our backend server, then the nonce received in the request and the nonce decoded in the identity token should be equal. Next, we need to look for a library which can convert a JWKS, means the JSON Web Key Set, which I have just shown coming from the Apple, to a public key. And in Java, Python, Node, etc., we have a lot of libraries which can do it easily. I'll do the same in Java to show you like how we can convert the N and E into a complete public key. I'll show you everything. So let us first understand the components returned by Apple in the public key JSON. So here are the components. So this is a JSON Web Key Set, like I said, JWKS. If you remember the header of the identity token, it has two things, KID and ALG. So KID is something which is the key identifier. So the token consists of KID, and in the public key JSON list, we also have a key identifier, and we need to match which key we need to pick up to make the public key so that we can verify the JWT token. Next is the algorithm. Now, what is N? N is modulus, E is exponent, and with the help of these, we can create the RSA's public key and verify the identity token. Now once you see the identity token, we can see this is the key ID in the identity token. So this key ID should be one of the key IDs in the public key auth keys of Apple. Okay, so I'm going to write this service, so I'm going to call this, and if you match this PGGNEQ, and it should be somewhere here. So this is the public key which Apple is using for this identity token. So what I need to do is to create this JWKS into an actual public key. So what I'll do, I'll copy this, and there is a service here in which JWK to PEM is done, and I'll copy this and I'll submit it. Okay, and I got the public key here. So I'll copy this public key for the time being, and I'll just write public key online. So I online got this public key, and I'll validate this public key with this identity token. How I can do it? So again, this is the complete thing I'm getting in the signature. With this, currently the signature is verified, and once I remove this and I add my public key here, so you can see the signature is again verified. So this is how we actually verify our identity token, whether it's a valid identity token from the Apple's public key. So from converting the JWKS to an actual public key with the use of modulus and exponent, and we get this public key, and then we verify it. So suppose if I just delete this B at the end, so this will be an invalid signature, or I add anything else like D, this will be again an invalid signature. So again, this is how the token is verified. So this is one way using some online platform, but obviously you have Java, Node, etc., a lot of backend languages where we can make this very easily. I'm going to show you this complete public key making which we done online using Java. Okay, so let's do some Java code. So this is the class I've written. This is a public key generator, and I need to pass only the two things which I'm getting from here. One is the AQAB. Okay, I'll go back to Visual Studio, and this is AQAB, and I need to also change this modulus. So this is all in base 64. So I'll just copy this N. Okay, and I'll go to Visual Studio and paste this. Okay, so this is taking everything in base 64 in string format, and then it is converting in the big integer. I have already printed that as well, and finally it is creating a public key with the use of RSA algorithm, and finally I'll also print this public key. So let us run this code and see what happens. Okay, so this is the modulus, a long big integer, and this is the exponent. So everything is converted into decimal, and this is the public key. So let me copy this public key, and this is from my Java code. So I'll write here from Java, or from programmatically we can say. And if you see carefully, this public key is exactly same with this public key. So if I try to match, so this, let me just remove the white spaces. Okay, and then you copy this and you match, so both are exactly the same. So this is generated from an online service, and this is generated from the Java code. So ultimately you have to do it with your code, whether you're using Java or Python or anything, any backend language, so which can help you in getting the public key extracted from the JWKS, the JSON Web Key Set, with the use of the modulus and the exponent. Okay, and this is how you generate the public key. And finally, once you generate the public key, how are you so sure that this is the exact public key for this identity token and this is the correct signature? So we did one with this online service, and we checked that signature is actually verified, but we will be doing using our JWT project here, and we will be writing the code for the same as well to validate whether the identity token is actually valid with this public key or not. Okay, so let us write the function validate identity token, and we need few things now here. Okay, so let us copy the same private key data and private key path which is needed here. Okay, then I have to write a public key string which is coming from my Java code or from the online service, both are same. Okay, so I'll copy this from the Java code. Okay, this is my public key. Now, so we have to create the data from the public key string dot data return. We have to write the JWT verifier, data let verified and JWT, and this will be my claims dot verify, and here I will be writing the identity token which I got and the verifier, and verifier is this one and identity token is this one, or we can copy it from here as well. So let me write the identity token here, identity token. Okay, and this is my JWT identity token. I just need to print verified or not, that's it, and this will give me a true or false. Okay, so rather than creating a client secret, I'll just validate my identity token whatever I have received. So this is the public key, again reiterating, this is the public key I made from my Java code, or you can make it from the online service as well, and this is the identity token I received from the Apple sign-in AS Apple ID credentials, and I need to verify whether this is a valid identity token by the Apple's public key. So this public key again will help in verifying the identity token whether it's valid or not. So let me run the code and see whether it's verified or not. Yes, true. So ultimately your key is verified. So whatever I was doing here in the JWT I verified this here itself, the signature was verified. Okay, same thing I did it here in the code. With the help of this JWT library, I verified this identity token whether this is signed with this public key or not. Okay, let me just change something like, okay, I'll change this 5 to 4 and then let me verify this. It should give false. Yes, this is false now. Again reverting to 5. Okay, this is true. So this is how we verify the identity token. We first we first actually get the key ID, whatever the key ID is, with this identity token, and then with the help of this key ID we actually use our N and E to create a public key. This can be done with any of your backend technology stack. I have used Java for this, and it's super simple to get the public key here, and I'll just copy this public key in my JWT project, the testing project, and there the same identity token I took and I created a verifier with the help of this public key, and then we verified the token whether it's valid one or not. So this is a complete process how we can verify the identity token, first by the basic validation and then by verifying with the Apple key JWKS by making the key and then verifying the identity token. Let us understand authorization code. So we need to send this authorization code and identity token to our backend in the form of string. It's a single use grant code and it is only valid for 5 minutes. Used to get the access and refresh token, and it is also used to validate refresh token. Let us understand what we need to send in this service. The service is appleid.apple.com/auth/token. The body consists of the first parameter as client ID. Client ID is your bundle ID. You don't have to add any team ID. It's just your bundle ID or if you're using the Apple sign in web, then you have to use the services ID. Second is the client secret. It's a JWT token generated at our backend that uses the sign in with Apple's private key associated with our developer account. We already have made this client secret in the beginning of the video. Then the code, it's the authorization code received in credentials. So whatever the authorization code which we receive, we have to send in the form of string, grant type, authorization underscore code, exactly the same. Refresh token, it's received from the validation server during an authorization request. So if we have refresh token, we can also send the refresh token, and in that case the grant type will be refresh underscore token. But for the time being, we are actually validating the authorization code, so we have to send the grant type as authorization underscore code. And the redirect URI, so when we are using sign in with Apple in web, then it's the destination URI. After the authorization, it will redirect to this URI. It should be a proper HTTPS protocol with the valid domain name. The parameters marked in red are required fields. So here how the request looks like: appleid.apple.com/auth/token. So it has a body client ID, which we already discussed. It's the bundle ID of the application. Client secret is the one which we made in the beginning of the video. Code, the authorization code in string, which we have received in Apple ID credentials. Grant underscore type, authorization underscore code. And if you want to have redirect UI, if you're using sign in web, then you can have some URL. And the response will be like this. So first of all, you'll get the response with the code 200. And there will be 5 things in the response. Access token, the token type, which is bearer, always expires in 3600 seconds, 3600 seconds. This is the expiration time of access token. Then the refresh token, it doesn't have any expiry time. It actually expires if there is a change in the events, like a password change or the revoke thing, like that. And the ID token, which is the same which we have received in the Apple ID credentials. It is a little different in the string, but when you decode it, the contents will be the same. So let us copy this auth code and let us get the access and refresh tokens from this auth code. Okay, so this is the request. I'll copy the auth code here, and for the time being, I'll just going to hit this API without a client secret or maybe some dummy client secret, and it will give me an error, invalid client. Okay, so I have already made a client secret here. So once I copy this and I add here, so when I hit this service, you can see that I got the access token, which actually expires in 1 hour, the refresh token, and the similar identity token, which I already got here. Okay, so obviously the string might be different, but when you decode it, it's almost the same. Only the initial and the expiration time will be changed. So here we got the access and the refresh tokens. This is how we get it. I'm going to copy this and let me keep it here, somewhere here. And if I hit it again, so it will give me an error that this code is already being used. Okay, and the error is invalid grant. So you can get the access and refresh tokens once only, since this is a single time code and it is only valid for 5 minutes. Okay, if your access token is expired, then you can use the same endpoint and you can pass the refresh token to get a new access token, because the expiration time of access token is 3600 seconds. So you need to set 2 things here. First of all, you have to set the grant underscore type as refresh underscore token, and the refresh token which we got in the previous request when we sent the authorization code, we have to send that refresh token. And in the response, you will get 4 things: access token, newly generated access token, which is again valid for another 3600 seconds, token type as bearer, and the ID token. Okay, let us see how we can validate the refresh token. So we got the refresh and access token here. Okay, so let us copy this refresh token, and we have our client secret as well. So this is our client secret. This is valid for 1 hour, so it should be valid. And when I call this service to validate the refresh token, it will give me a new access token. It won't give me any refresh token here, but it will just give me a new access token. And if you see, the earlier access token was this one, which is different from the one which we received here. Okay, and this is now valid for the next 1 hour. So this is how we actually validate our refresh token, and this should be done once a day. If your servers allow, you can do it once a day, just to check whether that refresh token is not invalid, or anybody has not changed any permission or revoked, etc. So this is how we can validate the refresh token and get the new access token, which is again valid for the next 1 hour. Okay, so in this case we again receive an ID token, but I don't think we need to verify it, because we have already verified when we did the sign in with Apple request. So I think that is enough. The only thing is that you just need to call it once a day if you require, just to validate that user haven't changed any privileges. One more thing, again, the refresh token is something which never dies. Like, it stays, it only gets invalidated when we do some privilege changes, or we revoke the token, or we change something, stop using Apple ID, or delete the Apple ID, etc. In the next video, we are going to talk about token revocation, handling session changes, and delete account.